So today what we were going to talk about is about a common technique for solving a quadratic known as completing the square, and then we're going to do something very special with that same technique, but I'll let that be a surprise for you. Now, for the next few minutes, sit back, relax, and enjoy. So here we go. So we're going to begin with a simple problem. X squared plus 3x squared plus 3x plus 2 equals 0. We're gonna solve this problem by completing the square. So the first thing we're gonna do is we're gonna subtract 2 from both sides, and this is gonna give us x squared plus 3x equals 0. Equals, forgive me, negative 2. Right? Equals negative 2. Now the key idea with completing the square is that you want to find a way to express this in a way that will allow us to take a square root. And so the way we do this is like this. Someone way back in history thought of this brilliant technique. It goes all the way back to the Babylonians, in fact, where they thought about this. Check this out. This is a random number here. X plus s squared equals x squared plus 2sx plus s squared. Right? I just did the FOIL method. I can show that to you over here. X plus s, right? And multiply these two gives me x squared. These two give me plus sx. This one gives me plus sx. And this one gives me the plus x squared, s squared. And then when you simplify these two, you can add them together and it gives you x squared plus 2sx plus s squared. Right? So it's nothing but the FOIL method, otherwise known as the happy face method. And you know, I always have a happy face on, so I mean that's a very good thing. But so we have that. And the whole idea is that we want this to be this, x squared plus 3x. So what we have here is that we want this 2s to be equal to 3. Right? So let's imagine that were the case. 2s equals to 3. Then s would have to equal 3 halves, because we divided both sides by 2. And then s squared would equal to 3 over 2 squared, which would equal to 3 over 2 times 3 over 2, which would equal to 9 over 4. Like this. Yes? And so that means that if we have x plus 3 over 2 squared, we get x squared plus 3x plus 9 over 4. Right? Now check that out. That is exactly what we want. Watch what I'm going to do here. I'm going to take this and I'm going to rewrite it as x plus 3 over 2 squared, right, which will equal to x squared plus 3x, but it also has plus 9/4. So this will have this plus 9/4, but this equals to this only. So when they're equal, and this one has an additional plus 9/4, then I have to add a plus 9/4 to the other side as well, in order for the sides to remain equal. Okay. So now what we do now is we simplify this side. Now, as you know, 2 is the same as 2 divided by 1. And what we want to do is we want to find a fraction such that we're going to multiply it times 2 over 1, and we're going to have a denominator of 4. But we're not going to disrupt the equality. So what we do is we multiply it by 1, but disguised in the form 4 over 4. And so now we have that this is going to equal this part over here. This other side is equal to negative 8 over 4 plus 9 over 4, which is equal to 1/4. Right? So now let's come over here to terminate this problem and solve it, or rather to finish solving it. right? So we have that x plus 3 over 2 squared equals 1/4, right? But, so now, this is the beautiful thing about completing the square. I can now take the square root of both sides. And that gives me x plus 3 over 2 equals the square root of 1/4. But the plus or minus the square root of 1/4. And that equals plus or minus 1/2. And the reason why it's plus or minus 1/2 is that when you square positive 1/2, you get 1/4. But when you square negative 1/2, you also get 1/4. So they both work. So that's why we get the plus and negative part. See? And now we're finally in a position to really solve this problem because we can subtract 3/2 from both sides, and so x equals negative 3 over 2 plus or minus 1 over 2. So that means that one solution is x equals negative 3 over 2 plus 1 over 2, which is equal to negative 3 plus 1 over 2, which is equal to negative 2 over 2, which is equal to negative 1. And then x equals negative 3 over 2 minus 1 over 2, which is equal to negative 4 over 2, which is equal to negative 2. And there we have it. These are our two solutions. Now you might say, so how do I know that these are the solutions? How do I know that these are the right solutions, right? So a common technique that I always recommend to all of the people I tutor is to just check. Once you've solved the problem, there's no reason for you to get it wrong, because you can check to make sure you have the right problem, so that you have the right solution. And the way you go about that is by plugging in. So I'm going to test this one first. So I would plug in for x. So I have negative 1 squared plus 3 times negative 1 plus 2. And I want to find out what this equals to. Now, as you know, negative 1 times negative 1 is 1, positive 1. Negative 1 times positive 3 gives you negative 3 plus 2. And now from left to right, now we're going to add. This is going to be added from left to right, and that's going to be equal to 1 minus 3 is negative 2 plus 2 is 0. So this is in fact a solution. And I will let you do this one at home. That way you can be able to test to see whether it's a solution or not. And so that is how you solve an equation by completing the square. So what we're going to do now is we're going to do something special. I always thought that this was super special, and I first read about this in our first course in calculus by Serge Lang, one of my favorite authors. And without further ado, I'm going to perform it for you. And it's exactly what we did, but except we're going to start with the general quadratic, which is like this, where a is not 0, right? Like this. So what we're going to do? The first thing we're going to do is we're going to divide the whole thing by a. So we're going to get x squared plus b over a, x plus c over a is equal to 0. Because 0 divided by a is still going to be 0. And then what we're going to do is we're going to subtract the c over a from both sides, right? And that's going to give us x squared plus b over a x equals negative c over a. Now, if you recall, what we want to do is we want to find a number s such that 2s is going to equal to b minus a. Okay, so we're going to have, if 2s equals b over a, then s has to equal b over 2a, and s squared, let me erase this over here, right? It's going to be b over 2a. And then s squared is obviously going to be b squared over 4a squared. So we're going to have x plus b over 2a squared equals x squared plus b over a x plus b squared over 4a squared. Like this. Now this is important because watch what this allows us to do. Watch what I'm going to do over here. I'm going to use this to complete the square over here. If you notice, this part is equal to this part. And so I can write this. X plus b over 2a squared, right, is equal to, now watch this. This squared is equal to this plus b squared over 4a squared, right? But this is only equal to this. So I need to add b squared over 4a squared to this side so that these will be equal, which leads me to write this as like this. And using our argument from before, we want to find a common denominator, add these. And if you notice, this is a, this is 4a squared. So 4a over 4a is the perfect fraction to multiply to get the common denominator. Multiplying this out, we get negative 4ac plus b squared over 4a squared. Like this. We can now divide, we can now take the square root of both sides. And that's going to give us this. It's going to be x plus b over 2a equals this plus or minus the square root of negative of b squared minus 4ac over 4a squared. Now, if you notice, this bottom is 2 times 2 and 8 times 8. So 2a squared is in the bottom, right? So this is going to actually simplify to plus minus the square root of b squared minus 4ac over 2a. So, what I'm going to do to finish this problem is that I'm going to erase all of this other part over here. And I'm going to put the final finishing touches on this solution over here. I'm going to subtract this from both sides now. So I'm going to have x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, obviously, you can see that this immediately implies that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The quadratic formula. This, as you've just noticed, can be derived directly from this using completing the square. I hope you've enjoyed this, and I look forward to hearing from you soon. Bye.